Functions. One of the reasons people go nuts over Lisps is that these languages let you build programs that behave in complex ways. Yet the primary building block, the functions, is so simple. This section initiates you into the beauty and elegance of Lisp functions by explaining the following. Calling functions, how functions differ from macros and special forms, defining functions, anonymous functions, returning functions. Calling functions. By now you've seen many examples of function calls. Remember that all Clojure operations have the same syntax: opening parenthesis, operator, operands, closing parenthesis. Function call is just another form for an operation where the operator is a function or a function expression. An expression that returns a function. This lets you write some pretty interesting code. Here's a function expression that returns the plus addition function. That return value is the string representation of the addition function, because the return of OR is the first truthy value, and here the addition function is truthy. The addition function is returned. You can also use this expression as the operator in another expression. Because OR plus minus returns plus, this expression evaluates to the sum of 1, 2, and 3, returning 6. Here are a couple more valid function calls that each return 6. In the first example, the return value of end is the first false value or the last truthy value. In this case, plus is returned because it's the last truthy value and is then applied to the arguments 1, 2, 3, returning 6. In the second example, the return value of first is the first element in a sequence, which is plus in this case. However, these aren't valid function calls, because numbers and strings aren't functions. If you run this in your REPL, you'll get something like this. Take the map function, not to be confused with the map data structure. For instance, map creates a new list by applying a function to each member of a collection. Here the inc function increments a number by 1. Note that map doesn't return a vector, even though we supplied a vector as an argument. You'll learn why in chapter 4. For now, just trust that this is okay and expected. Clojure's support for first-class functions allows you to build more powerful abstractions than you can in languages without them. Those unfamiliar with this kind of programming think of functions as allowing you to generalize operations over data instances. For example, the plus function abstracts addition over any specific numbers. By contrast, Clojure and all Lisps allow you to create functions that generalize over processes. Map allows you to generalize the process of transforming a collection by applying a function, any function, over any collection. The last detail that you need to know about function calls is that Clojure evaluates all function arguments recursively before passing them to the function. Here is how Clojure would evaluate a function call whose arguments are also function calls. The function call kicks off the evaluation process, and all subforms are evaluated before applying the plus function. Function calls, macro calls, and special forms. In the previous section, you learned that function calls are expressions that have a function expression as the operator. The two other kinds of expressions are macro calls and special forms. You've already seen a couple of special forms, definitions, and if expressions. You'll learn everything there is to know about macro calls and special forms in chapter 7. For now, the main feature that makes special forms special is that, unlike function calls, they don't always evaluate all of their operands. Take if, for example. This is its general structure. If, boolean form, then form, optional else form. Now imagine you had an if statement like this. Clearly, in an if expression like this, we want Clojure to evaluate only one of the two branches. If Clojure evaluated both tweet function calls, your tweet followers would end up very confused. Another feature that differentiates special forms is that you can't use them as arguments to functions. In general, special forms implement core Clojure functionality that just can't be implemented with functions. Clojure has only a handful of special forms, and it's pretty amazing that such a rich language is implemented with such a small set of building blocks. Macros are similar to special forms in that they evaluate their appearance differently from function calls, and they also can't be passed as arguments to functions. But this detour has taken long enough. It's time to learn how to define functions. Defining functions. Function definitions are composed of 5 main parts: define, function name, a docstring describing the function, optional, parameters listed in brackets, function body. Here's an example of a function definition and a simple call of the function. At 1, too enthusiastic is the name of the function, and it's followed by a descriptive docstring. At 2, the parameter name is given. At 3, and the function body at 4 takes parameter and does what it says on the tin, returns a cheer that might be a bit too enthusiastic. Let's dive deeper into the docstring parameters and function body. The docstring is a useful way to describe and document your code. You can view docstring for function in the REPL with doc fun name, for example docmap. The docstring also comes in play if you use a tool to generate documentation for your code. Parameters and arity. Clojure functions can be defined with 0 or more parameters. The values you pass to the functions are called arguments, and the arguments can be of any type. The number of parameters is the function's arity. Here are some function definitions with different arities. In these examples, no params is a 0 arity function. 1 param is a 1 arity, and 2 params is 2 arity. Functions also support arity overloading. This means that you can define a function so a different function body will run depending on the arity. Here is the general form of a multiple arity function definition. Notice that each arity definition is enclosed in parentheses and has an argument list. Arity overloading is one way to provide default values for arguments. If the following example karate is the default argument for the chop type parameter. If you call xchop with two arguments, the function works just as it would if it weren't a multiple arity function. If you call xchop with only one argument, xchop will actually call itself with the second argument karate supplied. It might seem unusual to define a function in terms of itself like this. If so, great, you're learning a new way to do things. You can also make each arity do something completely unrelated. The zero arity body returns a wise quote, and the one arity body increments a number. Most likely, you wouldn't want to write a function like this, because it would be confusing to have two function bodies that are completely unrelated. Clojure also allows you to define variable arity functions by including a rest parameter, as input the rest of the arguments in a list with the following name. The rest parameter is indicated by an ampersand, as shown at 1. As you can see, when you provide arguments to variable arity functions, the arguments are treated as a list. You can mix rest parameters with normal parameters, but the rest parameter has to come last. Finally, Clojure has a more sophisticated way of defining parameters called destructuring, which deserves its own subsection. Destructuring. The basic idea behind destructuring is that it lets you concisely bind names to values within a collection. Let's look at a basic example. Here the myFirst function associates the symbol first thing with the first element of the vector that was passed in as an argument. You tell myFirst to do this by placing the symbol first thing within a vector. That vector is like a huge sign held up to Clojure that says, hey, this function is going to receive a list or a vector as an argument. Make my life easier by taking apart the argument's structure for me and associating meaningful names with different parts of the argument. When destructuring a vector or list, you can name as many elements as you want, and also use REST parameters. Here the REST parameter unimportant choices handles any number of additional choices from the user after the first and the second. You can also destructure maps in the same way that you tell Clojure to destructure a vector or list by providing a vector as a parameter. You destructure maps by providing a map as a parameter. Let's look at the line at 1 in more detail. This is like telling Clojure, yo Clojure, do me a favor and associate the name lat with the value corresponding to the key lat. Do the same thing with lng and lng. Okay? We often want to just break keywords out of a map, so there is a shorter syntax for that. This has the same result as the previous example. You can retain access to the original map argument by using the as keyword. In the following example, the original map is associated with treasure location. In general, you can think of destructuring as instructing Clojure on how to associate names with values in a list, map, set, or a vector. Now, onto the part of the function that actually does something, the function body. Function body. The function body can contain forms of any kind. Clojure automatically returns the last form evaluated. This function body contains just 3 forms, and when you call the function, it spits out the last form, Jew. Here is another function body which uses an if expression. All functions are created equal. One final note: Clojure has no privileged functions. Plus is just a function, minus is just a function, and inc and map are just functions. They are no better than the functions you define yourself, so don't let them give you any lip. More important, this fact helps demonstrate Clojure's underlying simplicity. In a way, Clojure is very dumb. When you make a function call, Clojure just says map ? Sure, whatever. I'll just apply this and move on. It doesn't care what the function is or where it came from. It treats all functions the same. At its core, Clojure doesn't give two burger flips about addition, multiplication, or mapping. It just cares about applying functions. As you continue to program with Clojure, you'll see that this simplicity is ideal. You don't have to worry about special rules or syntax for working with different functions. They all work the same. Anonymous functions. In Clojure, functions don't need to have names. In fact, you'll use anonymous functions all the time. How mysterious. You create anonymous functions in two ways. The first is to use the fun form. Looks a lot like defn, doesn't it? Let's try a couple of examples. You can treat fn nearly identically to the way you treat defn. The parameter lists and function bodies work exactly the same. You can use argument destructuring, rest parameters, and so on. You could even associate your anonymous function with a name, which shouldn't come as a surprise. If that does come as a surprise, then surprise. Clojure also offers another more compact way to create anonymous functions. Here is what an anonymous function looks like. Wow, that looks weird. Go ahead and apply that weird looking function. Here is an example of passing an anonymous function as an argument to map. The strange looking style of writing anonymous functions is made possible by a feature called reader macros. You'll learn all about those in chapter 7. Right now it's okay to learn how to use just these anonymous functions. You can see that this syntax is definitely more compact, but it's also a little odd. Let's break it down. This kind of anonymous function looks a lot like a function call, except that it's preceded by a hash mark. This similarity allows you to more quickly see what will happen when this anonymous function is applied. Oh, you can say to yourself, this is going to multiply its argument by 3. As you may have guessed by now, the percent sign indicates the argument passed to the function. If your anonymous function takes multiple arguments, you can distinguish them like this: %1, %2, %3, and so on. Percent is equivalent to %1. You can also pass a rest parameter with %ampersand. Returning functions. By now you've seen that functions can return other functions. The returned functions are closures, which means that they can access all the variables that were in scope when the function was created. Here is a standard example. Here, inc by is in scope. So the returned function has access to it even when the returned function is used outside inc maker.